Okay, let's start this live stream. So I have done some work behind the scenes. So we left in the index buffer here, but I have done the descriptor layout and the buffer and descriptor pool and sets. So this is the result. This is where what I have done. Make clean and make round. So this is it. This rotating square, not square but triangle, no, rotating rectangle, yeah, rectangle, yeah. So this is what I have done. So sorry for not recording that, but this is what we have. So and then new then 3 toggle C main. So yeah. So let's complete from where we have left. So alignments, one thing we've glossed over is so far is how exactly the data in C++ structure should match the uniform defined in the shader. It seems obvious enough to simply use the same types in both. However, that's not all there is to it. For example, try modifying the structure and shader to look like this. Compile your shader and your program and run it, and you will find that the color for square you've worked so far has disappeared. That's because we haven't taken into account the alignments. Triangle.verse. What? Run. Oh, run. Yep, it does. And the FPS is lower. FPX. So how to solve that? Vulkan expects the data in your structure to be aligned in memory in a specific way. For example, scalars have to be aligned by n equals 4 bytes given 32-bit floats. A vector must be aligned by int to n 8 bytes. Vec3 or Vec4 must be aligned by 4n 16 bytes. A nested structure must be aligned by the base alignment of its members rounded up to a multiple of 16. A mat4 matrix must have the same alignment as a Vec4. You can find the full list of alignments requirements in the specification. Our original shader with just 3 matrix 4 fields already meets the alignment requirements, as each matrix is 4 by 4 by 4 equals 64 bytes in size. Model has offset of 0, view and an offset of 64, and projection has an offset of 128. All of these are multiples of 16, and that's why it worked fine. The new structure starts with a Vec2 which is only 8 bytes in size, and therefore throws all of the offsets. Now model has an offset of 8, view and the offset an offset of 72, and projection an offset of 136, none of which are multiple of 16. To fix this problem, we can use the aligners specifier introduced in C++11. Will that work in C? City Online. Include CD online. Okay, it's working again. If you now compile and run your program again, you should see that the shader correctly receives its matrix values once again. Luckily, there is a way to not have to think about these alignments requirements. Most of the time we can define GLM for force default alignment gen types right before including GLM. This will force GLM to use a version of Vic2 and matrix 4. This has the alignment requirements already specified for us. If you add this definition, then you can remove the align as specifier and your program should still work. Unfortunately, this method can break down if you start using nested structures. Consider the following definition in the C++ code. In this case, F2 will have an offset of 8, where it should have an offset of 16. Since it's a nested structure, in this case you must specify the alignments yourself. These gotchas are a good reason to always be explicit about alignments. That way you won't be caught off guard by the strange symptoms of alignment errors. Yep, that's a good idea. Huh? Undo. This must be an alignment of 8. And let's test again. And it's still working. Okay. Don't forget to recompile your shader after removing the foo field. Multiple disk descriptor sets. As some of the structures and function calls hinted at, it is usually possible to bind multiple descriptor sets simultaneously. You need to specify a descriptor layout for each descriptor set. When creating the pipeline layout, shaders can then reference specific descriptor sets like this. You can use this feature to put descriptors that vary per object and descriptors that are shared into separate descriptors sets. In that case, you avoid rebinding most of the descriptors across calls, which is potentially more efficient. This is a long one.